So the peptide bond, sometimes referred to as omega, okay? It's largely fixed, so that leaves you with only 2 remaining bonds that can rotate. These are called torsion angles or dihedral angles. Here are all our peptide bonds in this chain. Okay? They are between our nitrogen, our amide nitrogen, and our carbonyl carbon. And then we have 2 other bonds that can rotate. Our dihedral angles are our torsion angles that can rotate. We have phi. This is the dihedral angle between the amide nitrogen and the alpha carbon. Okay? I like to memorize this as the H in phi. This is a hetero bond. It's between a nitrogen and a carbon, 2 different atoms. Okay? Hetero being different here, whereas the psi bond, the psi dihedral angle, is between the alpha carbon and the carbonyl bond. So this is the same. Okay? So this right here is our psi bond. Okay? Then we have our peptide bond. Then we have our phi bond. Psi bond, peptide bond, phi bond. Okay? Phi and psi. Knowing the phi and psi angle for every single one of these amino acids down the chain will give you a complete description of the backbone conformation. Not surprisingly, not all combination of angles is going to be allowed due to sterics. Okay. The next slide has a link. This link is already available for you online. I cannot stress enough what I think is the value of going through these resources. Okay? So go to files, go to supplementary resources, find the one that is for this content. Okay? It is, I think there's like 8 links. In fact, we can pull it up and we'll look at a couple of them right now. So when you go to that file online, it just says, well, they're outdated because I didn't update them, but it's the same stuff. It says Winter 19 supplementary resources topics being protein structure, primary through tertiary, torsion or dihedral angles, and Ramachandran plots, which we haven't talked about yet. I cannot stress enough the value of going through these. There's ones where it's a tutorial and it asks you to click on the bonds, sort of like quiz yourself. There's video ones. Go through these if you don't feel comfortable with this material. Okay? Like I said, excellent video defining phi and psi angles and their relationship in 3D, better than I could ever do. In words or with props. There's just something about those 3D renderings that we can't get to. So I want to play these 2. Hopefully they will work. This one I think is silent. It's like a minute long. Here we go. Have to drag it onto the screen. All right, the silence will be awkward. But the next one has a guy, I'm going to play the other one too. It has a guy talking, so that'll be less weird. But this will show you the actual rotation about these phi and psi bonds. So here we have our alpha carbon shown in yellow, these sweet 3D printed model, as you can see. Okay, and so then we have our phi bond between our nitrogen and our alpha carbon, and then we have our psi bond between our carbonyl carbon and our alpha carbon. And then this is our peptide bonds are over here. Okay, and they're going to show you the rotations about each of these bonds. So let's look at that quickly. And you can imagine as you got big groups on the side, the clashing that would occur. So we're going to read, we're going to look at something called a Ramachandran plot, which gives all of the phi and psi angle combinations. And so that's what this is, 0 to 180. That will help you understand what we mean by 0 to 180. I think that